Good evening, sir. Okay, thank you so much, sir. Okay, so good evening, everyone. If I'm audible, sir. Okay, friends, good evening to everyone. Today is the last day, last session of the 5-day FDP. And the agenda is I'm going to discuss correlation regression along with some of the caselets which can help you to understand which particular test you can apply, right? So I hope we can start. I think anyone who can respond.
Yes, ma'am.
Yeah, thank you so much, ma'am. Fine. So as a pedagogy I'm using in this FDP, I'm sharing my screen first. We'll talk about the conceptual aspect of correlation and regression, and then we'll see how we can apply these two using Excel. I shared my screen. I hope it is visible to every one of you.
Yes.
Thank you so much, ma'am. So starting with this session, I'll start the session at a note that from last, I think, 2 days, we are studying parametric test, right? And before that, we have seen the non-parametric test also. So in the continuation to the parametric test, today we are going to talk about the correlation and regression, right? So firstly, I'm taking the correlation part. And then we'll talk about regression. So anyone who can tell me what do you understand by correlation?
When we have two variables and we want to know that there is any linear relationship or not.
Okay. I think it was Indrani, ma'am.
Yes, ma'am.
Thank you so much, Indrani, ma'am. Anyone else? Anyone else? Yes. Who can tell me? No one?
Relationship between two different variables.
Okay, very good. Very good. Thank you so much, ma'am. So I think from the name tool, it's about technique itself. It is very clear when we are saying correlation means we are interested to find relationship using this particular statistical technique, right? So correlation can help us to find the relationship between variables, right? Apart from that, if we want to understand what other thing correlation does for us, so we need to understand this thing that when we are talking about correlation, it can help us to measure the strength of relationship. You can also call it as a degree of relationship. Apart from this, we can also find the direction, right? So the correlation is a statistical tool or technique which can help us to find the strength of the relationship between the variables, or we can say degree of relationship between the variables. Apart from that, we can also find the direction of relationship, right? So this is what correlation does for us, right? In this case, generally, we are not taking any variable as independent and dependent variable. So generally, we are generally taking two variables and we are not distinguishing between them as a independent and dependent variable, right? So we are having only two variables without keeping our mind that which variable is dependent and independent. For correlation, we can directly get the relationship between them. But if further we want to get some more insights from those variables, And that way we need to decide upon which variable you are treating as a dependent, which variable you are taking as an independent variable. Right? It is clear, I hope.
Yes, ma'am.
Fine. So moving ahead, talking about the types. So when we talk about types of correlation, there is simple correlation, partial correlation, multiple correlation, linear correlation, non-linear correlation, right? Positive correlation and negative correlation, right? So these are the types of correlation. In first case, when I'm talking about simple correlation, here simple correlation is what? When we are studying only two variables. So when you are studying two variables, you can call it as a simple correlation. In case of partial correlation, we are studying a few variables and not considering all possible variables, right? In multiple correlation, we are considering more than two variables. Then in linear correlation, generally the purpose is, means when I call it as a linear correlation, I can say the proportion of change will be same. Meaning is what? Means if I'm changing one variable by particular unit, other variable will also same by the same unit. So the proportion of change will be that ratio, that will be change ratio will be maintained there. So that way you can call it as a linear correlation. In case of non-linear correlation, the proportion of change will not be same. If I'm increasing one variable by suppose 2 unit, other variable is decreasing by 1 unit or maybe increasing by 1 unit. So that way proportion is not same. That way you can call it as a non-linear correlation. Positive correlation means when the change of direction is same. Means if you are increasing one variable, other variable is also increasing. If you are decreasing one variable, other variable is also decreasing. You can call it as a positive. Means when the direction of change is same, that is positive correlation. Opposite to this, when the direction of change is opposite, we can call it as a negative correlation, right? So, for example, if suppose we are getting a monetary benefit or monetary increment, it will definitely increase our morale or motivation level, right? It's a positive correlation. Similarly, when we are increasing the price but demand is decreasing, we can call it as a negative correlation. So the direction should be opposite, it is negative. But when the direction of the change is same, it is positive, right? So these are the types of correlation. I hope types are clear to everyone.
Ma'am, ma'am,
Hmm.
this positive correlation is showing the change is same, but not how much amount of change is there.
That is not it is not a matter of fact. Matter is direction
Okay,
should be
ma'am.
same. That is positive.
Okay, and the linear one is showing the proportion of change will be same, the
Yes.
percentage. Okay, ma'am.
Proportion means
Okay.
ratio. Yes, you can call it as that.
Ratio. Okay, ma'am.
Fine. So these are the types, right? Further, how to measure. So before talking about how to measure, we will talk about the variable requirement. So here I'm talking about the Karl-Pearson's coefficient of correlation. So generally we can have two variables, right? Now if variables are numeric, means if both the variables are numeric, right? These can be numeric also. These can be ordinal scale also. These can be nominal scale also, right? So when both the variables are numeric, you will go for the Karl-Pearson's coefficient of correlation. In case of ordinal, we'll go for Spearman's rank correlation. In case of nominal, generally we are going for the Kendall's tau, right? So according to the type of variables, you need to decide upon which correlation method you are applying to get the relationship between the variables, right? Then if I'm talking about, because we are discussing mostly used correlation, which is we are applying in case of numeric variables, right? So here we are talking about Karl-Pearson's coefficient of correlation. Now, if I'm talking about this, right? So as we know, we are numerically or symbolically, we are representing correlation by small r, right? So for the interpretation purpose, we need to understand what can be the, if whatever values we are getting, how we can interpret it. So we need to know this thing that R ranges between -1 to +1, right? This is the range. R cannot be less than or lower than -1. It cannot be greater than +1 also. So this R will be lying between these two. If we are getting just a minute. It will not. +1 meaning is perfect correlation. So perfect meaning, according to the symbol, you need to check, because the direction is positive and negative. How we are deciding? Deciding using the symbol of the R value. So if R value is plus, we can call it as a perfect positive. If R value is -1, we can call it perfect negative correlation, right? Then if I talk about further, I can say if R is less than 0.75, we can call it as a, not less than, we can call it as a greater than. We can call it as a strong positive or strong negative, right? When R is greater than 0.5, we can call it as a moderate. When R is less than 0.5, we can call 0.5, not 0.05. We can call it as a low or weak, right? So this way, this is a broad classification of the categories of the ranges of the R. That way, according to the symbol, again I'm repeating, you can call it as a strong positive or strong negative, moderate positive or moderate negative, or low positive or no negative correlation between the variables, right? So this can help you to understand what kind of relationship the two variables are sharing. Further, in the advanced statistics, if I'm talking about, a correlation is generally known as the basic tool, because it is a building block for the various advanced statistical tests. Even we need to know what type of relationship is shared by the variables, and then we are further deciding which test we are applying on the data, right? So that way I can call it as a correlation is a building block in the statistics, right? Still here I am clear?
Yes, ma'am.
Fine. Now further, if all the things still here are clear to everyone, now the last thing, if I'll talk about the correlation, which is known as causation. Causation is generally cause and effect relationship, right? Usually we need to understand, being a researcher, it is very important for us to understand this thing, that correlation is not a causation, right? Causation is a different phenomena, correlation is a different thing. So correlation is only the statistical test which can help you to understand that what type of relationship is shared by the two variables, whether the variables are strongly correlated, weakly correlated, or moderately correlated. But you cannot confirm using correlation that this variable will be my dependent, this variable will be my independent. That means which variable is making change, or which variable is causing change in the other variable, that you cannot confirm using the correlation. So correlation can only help you whether the variables are sharing strong correlation or the weak correlation. But you cannot comment that this variable can make this much changes in the other variable. That type of comment we cannot do using the causation. That means we cannot study cause and effect relationship using the correlation, right? So for studying that, we are having the next tool available named as regression. So correlation is not causation. Correlation is only a statistical test or tool which can help us to understand that what type of, or which means intensity of the relationship we can understand using the correlation. The better word, I think, and I can say this. So this is about the conceptual aspect of correlation. I hope till here I am clear to everyone.
Yes, ma'am.
Right. Now, moving ahead and talking about regression. So do I need to take regression first? I mean, all the conceptual aspect I need to discuss first, and then I need to go and perform all these things, or we need to firstly see correlation and then come back and we'll discuss the regression, as you see. Which way we will move?
Can we see correlation first and then after regression?
Fine, no issues. Now we'll. I think sheet is already given in the group, so I'm suggesting you open the sheet and click on the correlation. We select or open the first sheet named as correlation. I hope it is opened. Shall I proceed?
Yes, ma'am.
Now you can see in the data sheet, we are having the temperature variable available in the Celsius, and the sales of ice cream is given to us, right? Here we want to see whether these two variables are related to each other or not. So firstly, I am formulating my hypothesis. Anyone who can help me to find or formulate my hypothesis?
There is no difference in the
Significant difference between temperature and sale of ice cream.
yeah.
Okay. Difference
Between sale of ice cream and temperature.
Okay. I'm. I think who was interacting me? Ketki ma'am.
Ruchi,
Yes,
ma'am.
ma'am.
Ruchi ma'am.
Yes. Yes, ma'am.
Yes. So I think those who are here in the meeting, remaining people I'm talking about, except Ketki ma'am, Ruchi ma'am, please read the hypothesis and tell me whether it is correct or not.
I think a relationship should be there, a difference rather than difference. Because we are calculating the relationship between.
Very good, Ruchi ma'am. You've understood what I was pointing out. Thank you.
Thank you, ma'am.
So here we will write there is no significant relationship. Because correlation, I already said, we are using correlation for finding the relationship. Difference will not come here. And if you are reading the hypothesis with the difference word here, you can understand there is no significant difference in temperature and sales of ice cream. So whether these two are comparable, can I compare?
No,
Temperature
ma'am.
and sales of ice cream, right? So there is no point of writing difference word. Is it clear? Clear to all?
Yes.
Right.
Yes, ma'am.
So alternatively, I can say there is a significant relationship in temperature of and sales of ice cream. Right. Now, Hypothesis is ready. We want to test it at suppose 5% level of significance. So now to perform correlation in Excel, there are two ways. First one is you can use function. Second way is we can go and use the data analysis toolpack. So we will see in both ways, right? So I'm typing here equal and using the function called correl. I'll use this function, and what I need to do, I need to select the entire range of my data. You need to see I have selected the data range excluding the label. The labels are not excluded here, right? And then I close the bracket. So my range is B2:C11. Accordingly, you can check. And then you can press enter. So tell me, may I press enter?
Yes, ma'am.
Ma'am, I have one question.
Yes.
Ma'am, how to identify this that this data we are supposed to take means like here we are supposed to take with label or without label? Like
Hmm.
somewhere we have considered while selecting the data,
Hmm.
somewhere we have selected with the labels. I
I
mean with
don't
the
think
heading.
in case of function anywhere we selected using the labels. Functions cannot take labels. Functions cannot differentiate between your numeric data and your text data. So functions only working on the numbers. So you need to always provide the range of your data. But
Okay.
whereas when we are using the data analysis tool pack, there is a clear option available of the checking of the label box. So there is
Okay.
a facility for you. You can go with the labels also. You can go with the without label also.
Understood, ma'am. Thank you very much.
Yeah. So may I click on enter?
Yes, ma'am. Sure, ma'am.
Yeah. After you have entered to field. Oh, sorry. Okay, it is wrong. What you need to do? You need to select your first column. It is taking an array form, and then put a comma, and then select the second column. So that way you can see the range will be B2:B11, comma C2:C11. Right? Clear? Clear, everyone? One series
Yes, ma'am.
at a time you need to select, put a comma, and select the second series. So you need to segregate your series by a comma and then enter. I hope everyone is getting the same figure.
Yes, ma'am. 0.75.
Right. So it is a strong positive correlation between temperature and sales of ice cream. Right?
Yes, ma'am.
Right. So this is the first way of getting the correlation value. Now we will see the second way. So we'll go to the analysis toolpack by clicking on the data tab or data menu. So click on that. Now click on data analysis toolpack, and here you need to serve the correlation. So it is listed after ANOVA. You can select it and you can click on OK. So I hope I can click on OK.
Yes, ma'am.
Yes, ma'am. Here we need to select or not anything.
Just a minute, I'm telling you, ma'am. Okay. So in this case, if I'm selecting my data, including the labels, so I need to select this checkbox, right? So you can see I selected the data including the labels B1:C11. So I need to select this checkbox. But if I will select my data from B2, in that case, I do not need to select this checkbox. Clear?
Yes, ma'am.
Fine. And then grouped by, our data is grouped by columns because data is available in a column, right? Now, labels are
Yeah.
selected because I told you the reason why I selected the label, right? Because I selected the data, including the labels. Generating my output in the same sheet, giving a blank cell. Clicking on OK. I hope I can click on OK. Done, everyone?
Yes, ma'am. Yes.
Now you can see temperature and temperature. In the same variable, we will always get the correlation value 1. In the temperature and temperature, correlation will be 1. In the sales of ice cream and sales of ice cream, correlation value is 1. But in the sales of ice cream and in the temperature, the same figure we are getting, which we are getting here, right? So that way you can see in both the way, we are getting the same value of correlation. Is it clear?
Yes, ma'am.
Right. Now, when we formulated the hypothesis, the hypothesis is talking about whether the relationship is significant or not. So I think from last 2 days we have been discussing about the significance of the things. So we know this thing that we need to have the p value. But when we have applied the correlation using the data analysis tool pack, even in that case also you can see we are not getting the p value, right? So this is the limitation of Excel. Excel is not providing you the p value in case of correlation. So for the purpose, in the sheet I have given you one formula of the t. This formula of the t we are using for getting the t value, which is based on the r value. You can see the formula says t equals r square root of n minus 2 divided by square root of 1 minus r square. Means this r we have calculated already. We need to supply this r value in this formula to get the t value. And you can recall we have already studied the p value, which we can draw using the t. So I think we will go in a t test and we will get the p value, right? So we'll do one by one. So I am calculating here the t statistic. You need to tell me, I think in a one go I need to show you a formula of firstly we will get the numerator, then we'll get the denominator, and then we will divide it. That will be easier for us to do. Okay, so I'm going with the numerator first. So what numerator is saying to you? The r value, right? It should be multiplied by the square root of how many observations? 10. So 10 minus 2. Clear? Is it clear? Friends?
Yes, ma'am.
Once I'll select and check we are having totally. Yes, 10 observations done. So numerator we have calculated. Now we will calculate denominator, which is square root of 1 minus r square, that is r into r, bracket close. Done. So may I enter?
Yes, ma'am.
Now we'll get the t statistic value, which will be the ratio of this numerator divided by denominator. Done? Everyone?
Yes, ma'am.
Shall I proceed for the p value?
Yes, ma'am.
Yes, ma'am.
So we will use t dot inv dot 2t. I think this is what we have used, right? No. Was this? This was the function. Right? Selecting this, degrees of freedom will be 9. Done? Fine, everyone? Shall I?
Yes, ma'am.
So we are getting 0.01015, which is less than.
0.05.
So that way, what we will say,
Reject is not.
Reject.
we'll reject the null hypothesis and we'll conclude there is a significant relationship. Now, significant positive also we can add because the value of this R is positive, right? So we can call there is a significant positive relationship between the temperature and sales of ice cream. Means if temperature is increasing, sales of ice cream is also increasing. This is the meaning, right?
Yes, ma'am.
So this is about correlation. Next practice sheet you can use for your practice purpose. Coming back and discussing the regression now. Till here, I think no doubt in correlation it was easy, right?
Yes, ma'am.
Right. Coming to the regression. So regression is a step ahead from the correlation. Correlation can help you to identify the relationship between the two variables. Regression is also doing the same thing. So firstly, I'm writing correlation is prerequisite, right, for regression. Means to perform regression, we need to have the idea about the relationship between the two variables, whether the variables are weakly or strongly related. If variables will be strongly related, that means there is a chance that your dependent or your independent variable is impacting your dependent variable, right, in a large or with the large intensity, that we can say. So that is why to perform regression, we need to always have an idea about the correlation. So it is like if we are performing regression, in the output of regression, we will always get the value of correlation. Whatever software we are using, in every software, always in the regression, we are getting the value of correlation also, right? So that is why I have written correlation is a prerequisite for regression. Then coming to the regression, I can say regression is helping us to find the algebraic relationship between variables. Algebraic means you can quantify the relationship between the variables. So quantification of the relationship is possible using regression. Whereas in the correlation, it was not possible. If I am saying correlation value is 0.75, I think we have just seen here, right? Here we have seen correlation value was 0.75. That means there is a 75.33 or 34% relationship between the two variables. So this relationship is in the form of percent. But the regression can give you the relationship in the quantify and the quantity also. That is why I'm calling it as a algebraic relationship, or you can quantify the relationship using the regression. So apart from this, you can also use regression for forecasting purpose. You can forecast or predict DV using IV or IVs. Then modeling between variables is also possible when we are talking about regression. So these are the list of the works which we can do using the regression, right? You can understand the algebraic relationship between the variables. You can quantify the relationship. You can forecast your dependent variable. You can also model your variables using the regression. Is it clear to everyone?
Yes, ma'am.
Right. Further, coming to the I think I'll talk about assumptions also here, because some of the assumptions we can check in case of regression using Excel, right? So usually here we are talking about firstly the linear regression. First thing, so the assumptions will be in that form only. So when I'm saying linear regression, generally we need to have DV and IV, right? Two variables we need to have dependent and independent. As I already told you, in regression you can easily understand cause and effect. So I think one more thing I can write here, causal relationship can be studied here. Because when I'm saying prediction kind of things, it is only possible when we are studying the cause and effect relationship, right? So the assumption, if I'm saying we need to have independent and dependent variable, and these assumptions are for the simple linear regression. So there are two linear regressions, simple and multiple. When I'm saying simple linear regression, meaning is what? It is depending or it is having only two variables, one independent and one dependent. So these will be numeric here, right? Apart from that, there are certain assumptions which are for the residual. So residual, I'll explain you what is residual. Here we are talking about the normality of the residual and the equal variance of the residual. These are the important, what I can say, assumptions of the regression, and maximum assumptions of regression is based on the residual value, right? So I'll explain you what is residual value. Before that, I'll talk about the types of linear regression. So there are two varieties, simple and multiple. In case of simple regression, we need to have two, or you can write one PV and one IV, and both should be numeric, right? Then in case of multiple linear regression, we need to have one PV and more than one IV. So here these can be numeric as well. So DV should always be numeric. Right? IV can be numeric. IV, not IV, it's IVs. These can be numeric as well, categorical as well, and can be both also. Means combination, one can be numeric, one can be categorical, likewise also. So that is the requirement of multiple linear regression. I hope it is clear. Types are clear.
Yes, ma'am.
Right. So if types clear, assumptions also means I have not told you all the assumptions, but whatever we can check using Excel, that I have told you. So residuals, if I'm talking about, so before going into the residual, I need to tell you one more thing. That is the equation, because we are doing modeling in regression. So equation of regression. I think we all have studied one equation in the school time. I hope we have studied this.
Yes, ma'am.
What this equation is known as? What we call it? Call this equation?
Linear equation.
Regression equation of y on x.
Sorry?
Screen is not visible.
Okay. Now?
Yeah, now it is visible, ma'am.
Mhm.
Y is equal to a plus bx. Regression equation of y on x.
Okay. In school time, what
The
we
line of
studied? We have, yes, yes.
line of best fit.
Okay.
Straight line.
Straight line. Yes. Who
Straight
said
line.
this?
Yeah, sorry.
Who said this?
Pallavi, ma'am. Pallavi.
Pallavi?
Harshita.
Harshita ma'am. Very good. This is a straight line equation. In the school time, we all have studied this equation, which is known as y equals to a plus bx. When I call or when I talk about the regression, in regression, there is a little change in the equation. Generally, we are writing y equal a, maybe alpha also. You can find in some books we are reading it as alpha also, right? So the change is of this. So this is this regression equation, right? So now here we can call that y will be our dependent variable, x will be our independent variable, right? A will be intercept,
Intercept.
B will be
Slow.
post,
Slow.
and E will be
Error or
residual
residue.
or error terms, right? So this is the difference in mathematical equation and statistical equation. In mathematics, this is only the equation known as straight line equation. But in statistics, we are balancing this using this residual, right? Because as I said, we are forecasting using the regression, right? Say for example, I want to forecast the sales of a company using the advertisement expenditure. If company is spending this much in the advertisement, what is or what company can expect in terms of sales, right? I want to predict the sales of a company. So we know this thing, whatever we are predicting, it will not always be 100% correct, right? There can be some deviations also. So that way we are balancing this equation by adding this term, which is known as error term or residual term, right? So the residual is what? It is nothing but it is the difference of actual and predicted value, right? So if I'm saying, suppose the sales of company will be 1000 unit in the next month, but suppose it is coming as 990 units. So the deviation is known as that the deviation of 10 units is known as residual value or error value. Means my model is not that much perfect, which is 100% or accurately telling me the forecasted value of my dependent variable. Is it clear?
Yes, ma'am.
Right? So this is known as error term or residual. So maximum assumptions of a regression are lying around this residual value, right? So it is very important because if residual values are very high, it is very clear indication that your model is not a good model. Your model, whatever model you are fitting, this regression is generally known as modeling we are doing in a regression. So this model is not a good model because using this model you cannot forecast accurately or not even not very near to the accuracy we will not come if error terms are very high, right? That means there are some problems. You need to see what type of problems are there in our data. You need to check your data. Maybe advertisement expenditure you are providing, there are certain problems. You need to check those data. So that way you can understand the importance of these equation in regression, right? There can be some other names of this y and x variable. Sometimes y is also known as output variable, right? X is known as input variable, regressor. So there are so many terms we are using for x and y also when you are talking about regression. But broadly, to understand in easy manner, we can call them easily y dependent, x is independent variable. Clear to everyone?
Yes, ma'am.
Yes, ma'am.
So I think this was the basic understanding I want to give you for the regression. If it is clear, I think now we can proceed for the performing of regression using the Excel. Done? Shall I?
Yes,
Friends?
ma'am.
Yeah. Open the sheet named as regression. Got it, everyone?
Yes, ma'am.
Now you can see we are having two variables available, COVID cases and masks sold. For the regression or for performing of the regression, it is imperative for us to understand which variable is the dependent and which variable is the independent variable. So please tell me, two variables are listed, COVID cases and masks sold. Which variable we can take here as a dependent and which variable we can take here as an independent variable?
Mass sold is the dependent variable.
Yeah, and
Masks
COVID
sold,
cases are independent.
The COVID cases.
right? Many a time it happens that we can change also. Means in many variables, sometimes it happens that they are having the quality. They can be the dependent also. They can be the independent also. So you need to be careful which variable you are taking as a dependent, which variable you are taking as an independent variable, right? In this case, it is quite clear that mass sold will be the dependent variable, which is depending upon the COVID cases. So according to the number of COVID cases, we can have the mass sold. or we can say that this can be the sales of the mask, right? So using the past 12 years data, we need to fit a model between these two variables, right? So firstly, we will write the hypothesis here. Anyone who can tell me?
There is no significant relationship between marks sold and COVID cases. Null hypothesis, H naught. And there is a significant relationship between marks sold and COVID cases. Alternative hypothesis.
This is a way of formulating the null hypothesis and alternative hypothesis. But apart from this, if you want to be more precise, I will write my hypothesis like
Okay. There is no
as
significant
yes,
impact.
as we are studying the cause and effect relationship, I said regression is more help means more helping us in finding the cause and effect relationship between the variables. So if we can find, I think we can write more clearly that which variable is impacting the which variable, right? Is it clear?
Yes, ma'am. Yes, ma'am.
Right.
Yes.
Yes, ma'am.
So this is a way of formulating the null and alternative hypothesis. Now we will proceed and perform the regression, right? So I suggest you go to the data analysis toolpack under the data tab, right? Go down and search regression will be there. Yes, regression is here. Select this and click on OK. So I hope everyone has located this. May I click on OK?
Just a second.
Yeah.
Ma'am, एक मिनट wait कर.
I'm waiting. You need to tell me only whether you people are ready or not, and then I'll proceed.
For me, it is not showing, ma'am. Data analysis tab is not showing. Data, I clicked on data.
Okay.
But then,
Have you added it previously?
ma'am, I'm doing it. Like previous, all I have done with data analysis.
Sometimes it
But right
happens.
now,
I think you have noted down. I have said this thing. Sometimes it happens with the data analysis toolpack. Maybe you can close Excel, open it again. This way it will come.
okay.
Or maybe you need
Okay.
to shut down your device and again you need to restart it. So maybe you can restart your device. That way it can again show you that. If not,
Okay,
you
ma'am.
can again go and perform the process of adding it. Yes, ma'am. Anyone? Who is saying?
Same thing happened with me. I'm not finding this. I'm clicking on data, but I'm not getting the
You
data.
can do the process, ma'am. Either you can add it from the file menu options add-ins, you can do the same process. If it is not showing, in that case you need to restart your system. That is a problem. Sometimes it happens with the analysis toolpack.
Okay, ma'am.
So means with the once you are using it regularly, I think that way you will be not facing this problem.
Okay, ma'am. Okay.
So tell me what I need to do. Do I need to wait?
No, ma'am, you can proceed, ma'am.
Fine. So those who are not unable to perform or maybe stuck somewhere, they can note down what you need to do, right? I think it is clear to everyone how to reach to the regression, right? So that way I located this and I'm clicking on OK. So once you're clicking on OK, the box is coming like this, right? Yes or no?
Yes, ma'am.
Yes.
Right. It is asking you to provide the range of your data. So I think we have just decided by here you can see it is clearly asking input y range. Y means the dependent variable. So we just discussed that dependent variable will be the mask sold, right? So you need to select the column where the mask sold values are listed, right? Including the label I did that. Done?
I'm sorry to interrupt you. Can I share my screen and show you what the things are happening with my side?
Just a minute, I need to stop share my screen. Okay. Yeah, show me.
Yes, ma'am. I'm going to.
I got the
Yes,
result.
Good.
ma'am.
Yes.
Uh, are you able to see my screen?
Visible, visible.
Yes, ma'am. So here I just click on data and where to go now, ma'am?
I said, I think previously you performed, right?
Yes, ma'am.
Previously you have added the add-ins, right?
Uh,
Have you
no,
added the add-ins? What the first time you were performing it?
ma'am. I'm performing this
For
now.
the
I'm
first time? Or previously also you have done this along with us?
no. I'm doing first time today.
So you need to add the add-ins, ma'am. You need to go to the file tab,
File tab,
options,
options,
add-ins.
mm, add-ins.
Go down and find there will be a go button. Click on that. Bottom, bottom.
Yes, ma'am.
No, not here.
Okay.
Next section, manage. Go down in the panel in that particular box. Yes. Go button. You can see the go button. Yes. Next. Yes.
Yes.
Now select the first option.
Yes, ma'am. Can I click OK?
Yes. Now go to the data analysis toolpack.
Yes, ma'am. I'm going.
Okay. So may I start sharing my screen?
Yes, ma'am. Yes, ma'am. Please.
Yes, ma'am.
Okay, sir. Thank you. Thank you, ma'am. Okay. I hope my screen is visible.
Yes, ma'am.
Yes, ma'am.
So I think I again I'll go to the analysis toolpack. I'll select regression, click on OK, and I said to you, you need to select the range of your y variable. So in our case, y variable is what?
Marks sold.
Is the mass sold? Yes. So we need to select the range of mass sold variable, right? So I'll come in the box. I'll select the column where the mass sold values are listed, including the label. I did that, right? So my range is E1 colon E13. Coming to the next box, that is for the input X range box. Here I'm selecting the next variable, which is COVID cases. So my range is D1 colon D13, right?
Yes, ma'am.
Everyone
Yes,
is
ma'am.
fine. Now labels are selected, so I'm checking the labels box, right? Constant, I don't want to make my constant. I have already told you y equals a plus bx. So a and b are the constant. I don't want to make them zero. I don't want to make a as a zero value. So I'm not checking this box. Confidence interval value will coming as a 95%. So I'll okay with this. I'm not changing anything. Output I'm generating in the same sheet. So I'll select the particular cell where I want to generate the output. Till here, I think it is okay with everyone. May I go ahead?
Yes, ma'am.
Yes, ma'am.
Now, for the assumptions, you need to select the residual plots, line fit plots, and the normal probability plots.
Residual
Right?
plots, line fit
All the
plots,
plots,
and
all three plots.
okay.
Done?
Yes, ma'am.
Now click on OK. So in few seconds, output will be generated.
Yes, ma'am.
Got it?
Yes, ma'am.
Fine. So I'm explaining you the output now. I hope everyone has got. Now please pay attention, because maybe those who are very new to regression, maybe they need to note down few things, right? Starting with the first table, that is a summary table of regression, we are getting here the multiple R value. Multiple R means nothing but the correlation value, which is coming as 0.98. So it is indicating you strong positive correlation, right, between the mask sold and the uh, COVID cases, right? Clear? First one is simple, I think, right?
Yes, ma'am.
Next is the R square, and next to this is the adjusted R square. So both I'm telling you here. Interpretation will be the same for both the R square and adjusted R square. Only you need to see which R square you need to report when. If you are talking about simple linear regression, you will report R square. If you are talking about multiple linear regression, you will report adjusted R square instead of R square. Clear? Simple linear regression, R square. Multiple linear regression, adjusted R square. Done?
Yes, ma'am. Yes, ma'am.
Yes, and I think I told you the explanation will be same. So I'm only explaining you the R square here, as we are talking about the simple linear regression. So what R square is telling us? R square is indicating you the percent variance explained by IV in DV, right? So to make it more easier, I can say here I can call 95 or 96% variance in mask sold is explained by COVID cases, right? That means there 96% changes in the mask sold is explained by COVID cases variable, right? So it is a good variance because it is very close to 100%, right? Around 60% variance should be explained by your independent variable in your dependent variable. That means how much percent changes you can uh, explain using your independent variable in your dependent variable. That study we are doing using the R square. Is it clear?
Ma'am, can
Yes,
you
ma'am.
please repeat it once again?
How much percent changes you can explain in your dependent variable using independent variable. That is study we are doing using the R square. So we can say 96% changes are possible in the COVID, in the mass sold using the COVID cases value, right?
Okay.
Now, next is the standard error, which is 141.848. So there is no threshold value, so we cannot comment here. Observations are total 12 observations we are having. Next comes ANOVA. So in regression, we are getting correlation also, we are getting ANOVA table also, and even we are getting the T values also. You can find here. T values also are there, right? So what is the implication of ANOVA in case of regression? So it is very imperative in case of regression. What is the importance of ANOVA here? Importance is that ANOVA is helping you to comment on the model fitness, whether the model is a good fit model or not a good fit model. So that you can communicate using the significant value, that is the P value. So this P value is again a very small figure, I think, right? Less than 0.05. That means you can say your model is a good fit, or fitness of your model is good. So ANOVA can help you to comment on the fitness of the model, and using the significant or the P value of ANOVA, we will comment like this. If it is greater than 0.05 means your model is not a good fit, or your model is not a good model, right? Clear to everyone?
Yes, ma'am.
Yes, ma'am.
Going down, talking about the important table here, which can help you to build your model, right? So there you can see intercept, that is the value of A, or maybe alpha also you can call it. In some books you can find the y equation is y equals to alpha plus beta x, right? So A and alpha is one in the same thing. This is intercept value, right? Next is COVID cases coefficient value, which is this. That means this is your B or beta, right? So these are the two values you are getting. But before formulating your model or your equation, you need to comment on these two values, whether these two values are significant or not. So the role of this T and SP value is only here that these two things can help you to comment on the significance of the intercept and the coefficient of this independent variable, that is COVID cases. So this A and B, whether A and B are significant or not, that you can understand using the p value of the t-test. So both the p value you can find, this p and this p. Both the p values are less than 0.05. Yes or no?
Yes, ma'am. Yes.
Meaning is what? That means intercept and coefficient of IV both are significantly contributing to your DV. This is the meaning. Clear? Fine, everyone?
Ma'am, this COVID cases p value, this is mentioned 2.43 E. So how come like this is less than 0.05?
Okay, Pallavi ma'am, I
I
think it is
didn't get
Pallavi,
it.
right? Who is
Yes,
his
ma'am.
name? Pallavi. Have you joined previous sessions also, ma'am? In that we have discussed this thing.
Yes, ma'am.
So I think I told you this is nothing but it is 10 to the power minus 8. Exponential value, it is E, 10 to the power minus 8. 2.43 into 10 to
Okay,
the
so
power
how do
minus
we?
8.
Okay, okay, ma'am.
Right?
After solving this, we'll get the value. Yes, ma'am. Understood.
It will be less than very small figure. Before this 2, there are
Okay,
8
okay.
zeros, you can say like this.
Yes, ma'am, because it is minus 8, 10 raised to the power minus 8. Okay.
So there will be around 8 zeros before the 2. So it is a very small figure.
Okay,
Right?
ma'am.
So we can
Okay.
say both are
Yes,
significantly
ma'am.
both are significantly contributing to the dependent variable. So if these are contributing significantly, now we are making our model here. That is done. Done, everyone? Friends? Done. So if suppose on a particular day we are having the data of COVID cases, that you can supply here, multiply this by this figure, subtract this, so that way you can predict that this will be the mask sold, or this will be the prediction of the sales of the mask. Right? Clear? Friends?
Yes, ma'am. It's clear.
Right. Coming to the graphs, I think everyone is getting the graphs.
Yes,
Get
ma'am.
it?
Yes, yes, ma'am.
Right. Give me a second. I need to make it a little smaller so that I can help explain you on a single window. Right. All are visible, right? One by one, I will explain you. I will shift my screen here and there. Now you can see I'm talking about the first graph, which is residual plot, right? So just a minute, I will, yeah. Why I'm doing this, I'll explain you. So yeah, now you can see residual plot I'm explaining. This is the plot which is helping you to understand the variance of the residual, right? You need to see the middle line, which is the zero line, and then you need to see the different the blue squares you can see, right? So you need to see this thing. These data point means these are the data points, right? So these data points or residual points should be scattered almost similar, means above the zero and below the zero, these squares should be almost similar, right? So that way you can say that there is a homogeneity of variance of the residual. Apart from that, second thing you can see, if these points are forming any shape like cone shape, pen shape, any shape, if you can understand using these particular points, residuals. So that way you can say the assumption of the homogeneity of variance or equal variance is not met by the residuals. Clear? One thing, first thing, these residuals should be almost scattered equally below and above the zero line. First thing. Second thing, these residuals should not form any shape. Clear? So in that case, you can say this thing that these residuals are following the equal variance assumption. Is it clear, everyone?
Yes, ma'am.
Yes, ma'am.
Second is the normality plot, right? Thank you. Normality plot, you can stretch, right? If these normal means if these what I can say residuals, you can see if these residuals are going like this means just right. So you need to see this coming to the normality plot. Normality plot is generally used for commenting on whether the residuals are normally distributed or not, right? So for the normal distribution of the what I can say residuals, you need to see this particular what I can say this line, the line which they are forming. So this line should be approximately straight line. So that way you can comment that the residuals are following the normal distribution, right? Lastly, the COVID cases line fit plot. So this is nothing but this is indicating you, this is helping you to understand whether your model is a good fit model or not. So you can see the blue color squares are the mass sold value and the orange color squares are the predicted mass sold value. Means this is the actual value, blue one, and orange one is the predicted value. So you need to see these should be almost coinciding on each other. Means they should be on overlapping each other. If these are overlapping, that way you can say that your model is a good model. So that means the thing which we have commented using the ANOVA table, same you can comment using the visualization of these two figures, right? So you can find these are almost overlapping, almost not exactly but almost overlapping. These oranges squares are overlapping the blue squares. That way you can say your model is a good model, right? Or fitness of the model is good. So this way these three graphs can help you to comment on the what I can say assumptions of the residuals which are related to the residual. Clear to everyone?
Yes, ma'am. Ma'am, these are all plotted graphs. Is titled by you or labeled by you?
Sorry.
Miss, these all plotted graphs you labeled, no? Miss, COVID cases line fit.
No, I think same you are also getting. Have you labeled it? No. Excel is providing you everything.
Ma'am, I didn't label, but I'm getting miss, I'm getting like this. Miss, here is a 40 line fit plot. That's why I ask you.
What?
40 line fit plot, normal portability plot, and
Have
40
you selected that label?
this kind of label I have.
No,
That's
no, no. No, not here. In this data analysis tool pack, have you selected this labels?
Yes, ma'am.
So in
Yes,
that,
I got the plot also, which is just like as in your plotting terms, but I'm not getting, my plot is not having that kind of label. That's why I ask you.
What about in the remaining two?
Yes, let me read, madam.
Yes.
The one is a miss residential plot. There is again 40 residential plot in normal. Second one is a 40 line fit plot, and third one is a normal portability plot.
So 40 you are getting at two places, 40.
Yes, ma'am.
Is it possible for you to show your screen?
Yes, ma'am. Yes, ma'am.
Yeah,
Let me.
just a minute. I'm stop sharing.
Are you able to see my screen, ma'am?
No, I think it is. Yeah,
Yes.
yeah, I can see you.
Just see this. Yes, ma'am.
Okay. Can you go
This
to
is
the data
40.
tab?
Yes, ma'am. Let me.
Analysis toolpack. Regression. Okay. Only okay.
Yes, I click on label also. Whatever you mention, I just click with that. The all things are okay, or is it
No, it is
my
correct.
side, ma'am?
It is correct.
Okay.
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 Anyone else who is getting the same, like ma'am?
Shall I click on okay, ma'am?
If you will click
Miss,
okay,
shall I?
then send it again. You need to
No,
cancel.
I'm just saying, shall I stop my screen,
Just a
or
minute. You can
shall I
only
continue?
cancel out this particular regression dialog box and just wait.
Okay.
What about others?
Okay.
Friends, I hope everyone is able to see ma'am's screen. Please tell me.
Hello, madam. I am getting properly.
Sorry, you are getting?
Proper this level I get proper level. So what happened now? Ma'am is not selecting the selecting from A1 or C1 one row from
Range.
one row.
What the range you have given, ma'am? Please show again. Go to
Yes,
an analysis toolpack. Analysis toolpack. Data type. Yes. Click on. Yeah. Okay. Can you read the range, because I cannot read the range? It is
dollar C2
you can only
colon.
read it C2. You need to make it C1.
Okay. Okay. Shall I click here, or shall I
Yes,
go
yes.
against?
No, you can make changes here only. Type 1 in place
Yes.
of 2. Similarly, in the next also. And do one thing, come to the output range, first one. In the output option, select the first one this time.
This, shall I click here?
Hmm. Come to the box next to it. Click on the box. Click on the box.
This box?
The box, output range. Ma'am, output range, where you have selected first option, against it there is a box. Come in a box. Click on a box.
Which box, ma'am? Miss,
Against the output range.
against the
Yes, the first option you selected, no, output range.
yes, ma'am.
In the output options, first option you selected, output range. Next to
Yes.
this, there is a box. Click on that.
Here.
Yes. Now select any blank cell.
Okay. Which ones?
Blank cell. Scroll to the right.
Sorry.
Or more right, means beyond these graphs.
Yes, ma'am. Yes, I understood now.
Maybe you can, okay, you go there, click on this. Yeah. Oppose, and that right side, the right side will be, there will be an arrow on this particular, click on that.
Uh,
Below
Yes,
that
ma'am.
cross, click on this.
I'm not getting.
That cross, below that there is a little icon available. Click on that.
It's, I know how to select the range and all kind of things, but I'm not able to
I
go.
understand your point. You understanding. Maybe it is not helping, making you shift from here to there. So that is why I said click on that. Go back. Go back, ma'am. Yeah. Come to the box and type here.
Okay.
X2. Type here X2. Here, in the box. In the box, the cursor is blinking, na? Dollar.
Yes. Dollar,
And their dollar.
dollar,
X.
X,
Dollar.
again dollar,
2.
then
2.
2.
And click on OK.
Okay. Regression input range, non-numeric data. I think so. Some colon is missing or something is missing.
Dollar you have kept correctly because
Yes.
it's very small. I cannot read it.
Yes, I kept dollar properly, madam, and I click means I.
Do one thing, ma'am. Close this. Close this. Close the box. Regression. Close this. Maybe it is asking you remove everything. Close this. Yes, close it. Yeah, remove it and close it. Close it.
Okay.
Yes, cancel this also. Come to your data sheet wherever you have got the output. Wherever you are having the data, come to that sheet. Regression sheet. Regression sheet.
Yes, ma'am.
Yes, here you need to perform because that is a problem. Now here
Yes, yes. I got it now, ma'am. I have to select from this.
yes.
I actually selected this. Yes, yes. Thank you very much, ma'am. I'm sorry to interrupt you.
No, it's okay. It's okay. Totally fine.
Okay.
I think we
Okay.
need to thanks to the sir who has seen you not taking the correct range.
Yes, yes, ma'am. Yes.
Yeah. Thank you.
Yes. Thank you, ma'am. Thank you very much. I stop sharing and
So I'm start sharing now.
yes, ma'am. Thank you.
Yeah. Okay. I hope it is visible.
Yes,
Friends?
ma'am. Yes.
So at the means when you are going below, you can find we are having the residual output also, and we are having the probability output also. So that way you can see if you are using the line which we have used here, we can put the actual figures here. Suppose mass sold is 14. No, sorry. COVID cases are 40. So I can replace this COVID cases by 40. I will solve this. I will get this is the residual value in that case. Right? Getting my point? Predicted value, residual value. So you can calculate manually also, but Excel is providing you. So that way you can check out these are the residuals for the 12 observations. Getting me?
Yes, ma'am.
Right.
Yes, ma'am.
So this is about the simple linear regression. Now, without wasting our time, we'll go to the sheet named as MLR, that is multiple linear regression. Right? Practice sheet I already provided to you for performing the simple linear regression. Come to the MLR, that is multiple linear regression sheet. Right? You need to formulate your hypothesis. There is no significant impact of X1 on Y. Then there is no significant impact of X2 on Y. That way you can formulate your hypothesis here. Now this is a multiple linear regression because we are having the one dependent variable, which is Y, and two independent variables. So this is a case of multiple linear regression. We want to see what is the impact of these two on the Y, right? So now we are going on a data analysis toolpath. From here I am selecting the regression and clicking on OK. So you need to remove all the things which are there, because if you are using the same sheet, it is giving you all. I'm selecting everything here, right? Now, input Y range, select your Y variable. Input X range, select both the columns simultaneously. Provide the all the X variables together in this particular box, right? And then I'm selecting the labels because I selected the label, right? So I'm selecting the labels. Output I'm generating in a same sheet. And residual products, this time I'm not generating to make it simple, right? And clicking on OK. I hope I can click on OK. Everyone, it is fine.
Yes, ma'am.
Ma'am, please wait. Ma'am, please wait.
Ma'am,
Let
can
me
you please
perform.
do it once again?
You can ask me, ma'am. I said Y, it is clearly visible. You can provide the Y range. X, I said you need to select both the variables simultaneously, right? Labels are selected. Everyone know this thing. If you are selecting the label, you need to select this labels box and output wherever you want to generate. Only that I did till now. Please check, are you able to do so or not?
Ma'am, after data analysis, where did you click in this box, ma'am?
Regression
Data
only.
analysis.
Regression only.
Regression only.
Only one option
Okay.
available, yes.
For X
Okay.
range, we have to select X1 and
Both
X2
the
also.
variables simultaneously.
Yes, yes.
You can see in my case, it is B and C column together.
Done, ma'am.
May I click on OK? Done. Shall I go for the interpretation?
Yes, ma'am.
Yes. Just a minute. Yes.
I'm not getting summary output. I just show me your selected terms again. As I go to regression, I did all things, whatever you check.
Visible?
Yes. These all things are happening from my side, means done from my side. But
Okay.
still, I'm not getting the output. Summary sheet. Summary output.
Is it possible for you to show?
Yes, again, ma'am. Yes,
Okay.
I'm getting things, but I'm not getting the output. That's why.
No issues. I'm stop sharing my screen. If you
Yes,
can
yes.
share your screen.
How you are getting my screen? Hello, ma'am.
Visible.
Yes, ma'am. I just click on data.
Hmm.
Then I click on data analysis. Oh, super. Data. It's doing like this. This data. Data analysis. Yes,
Mhm.
regression. Okay. Then I selected this. Let me do again. See this. See, X. Sorry, Y range is this to
No,
this.
from Y itself, ma'am. We are not including Y. Include Y also. Why we are not including Y?
Okay, okay.
Delete this.
Okay.
Come down.
Sorry. Yes. And
Select X1, X2 together.
yes.
Check
After that,
the
I have to click
label. Yes.
the range is okay now. Output range is okay.
Okay.
X.
Then click on OK now. Okay.
Regression output range will override existing.
Okay. Okay. Click OK.
Okay. Yes. What about chart area?
Just a minute. Wait. Maybe it is generating.
Here it's showing me summary output, but I'm not getting that.
Where is your cursor right now? On which particular cell you are? X2. So, ma'am, I think it is there in a X2. Go there in a X column. It is only till now we can see T and U only. Go to the right side. Scroll to the right.
Yes, ma'am. Now I got it. Yes. It's a summary output.
Yes.
Yes. Okay. Thank you very much, ma'am.
Thank you, ma'am. So, shall I share my screen?
Yes, ma'am. Yes, ma'am. I stopped it.
Yeah. Right. So, in a hurry, we will complete this because at least 1-2 exercises I need to show you so that you can understand in the real world scenario how we can identify which test is applicable, right? So, here you can see our correlation value, which is 0.83, which is a strong positive correlation. R square we are not reporting. Instead of this, you need to report adjusted R square as it is a multiple linear regression. So you can say 61.4% variance in Y is explained by X1 and X2, right? Coming down, ANOVA value is 0.014, which is less than 0.05. You can say your model is a good fit, right? Coming to the next, intercept is this. X1 and X2 coefficient values are this. You need to see the p values. So if you will look at the p values, you can say you can say all the p values are less than 0.05. That means intercept X1 and X2 coefficients both are significantly contributing to your Y variable. Means these are different from 0. These are not 0. Meaning is that these three values are not 0. These are different from 0. This is the meaning. That is why they are contributing to your Y variable or in prediction of your Y variable. So this is the multiple linear regression. I hope it is clear. Yes. Anything?
Yes, ma'am. Yes.
Right. So now I'm just going to my Word file. We will see the small caselets here. So I'm expecting you, please come in a different mode now. Now this is the time where we will do a discussion kind of thing, where my role will be almost nil. You need to read the situation and need to tell me which is the test we can apply in this particular condition. All the tests which we have studied since till now can be applicable, right? So you need to see according to the information what is the appropriate variable, right? मम्मी सेशन में है, सेशन के बाद लगाते हैं, सेशन में है, क्लास में है अभी, है ना, लगा रहे हैं, आ रही है बाद में लगा रहे हैं मम्मी. हाँ, बाय. Yes.
Yes, ma'am. Yes, ma'am.
Anyone who can tell
We are
me?
trying to.
Yeah. No issues.
We are trying to.
Yes. No issues. Take your time. I'll do one thing. I'll stop sharing. I'll share my screen in another way so that I can also see you people that who are interacting with me. Visible now?
Yes, ma'am.
Yeah. So please read and tell me.
Madam, since it is an association, is it a correlation?
Okay.
It's a chi-square test.
It's a chi-square test. Okay. Anyone else? Chi-square and quotient, two answers we are getting. Any other opinion?
I think so. It's a correlation.
It's a correlation according to Vaishali ma'am also. Okay. What about others? Yes. Anyone else who wants to comment? Fine. Yes, Harshita ma'am.
Correlation.
It's a correlation. Ketki ma'am, it's a correlation. Okay. Harshita ma'am, you want to say something?
Chi-square.
Chi-square. So the persons, those who are saying it's a chi-square test are correct. You can see association meaning is relationship, but in which variables we are finding this relationship? In both the cases, you can find movie genre, genres, and the class levels. Both are the categorical variables. So in categorical variables, if we are finding the relationship, we will go for the CARE word. It is clear?
Yes, ma'am.
Next
Yes,
situation.
ma'am.
I hope visible.
Yes, ma'am. It's visible.
Yeah.
Yes.
Ma'am, two-tail test.
Two-tailed test. Two-tailed
मतलब
test.
वो and वो ANOVA.
ANOVA. Okay. Two-way ANOVA.
Two ANOVA.
Okay. Fine. Fine. Anyone else?
Two ANOVA का पूरी है.
Yes. Anyone else?
Two-way ANOVA.
Two-way ANOVA.
Two-way
Very
ANOVA.
good. Rajshri ma'am is writing chi-square. No, it's a two-way ANOVA case. Clear. Why so?
Yes.
Because we are having two independent variable, that is temperature, and in temperature we are having two categories, high and low temperature.
Yes, ma'am.
Right?
Yes,
In the
ma'am.
type of sugar, two variables,
That's right.
white sugar, brown sugar. So we are checking the impact of temperature on the weight of cookies and the type of sugar on the weight of cookies. So weight of cookies is a variable which is numeric, right? So that way, two independent variable and one dependent variable, we can go for the
Two-way ANOVA.
two-way ANOVA. Very good. One more problem, may I take?
Yes, ma'am. Sure, ma'am.
Yes, ma'am.
Yeah.
Ma'am, third one we have to analyze now.
Sorry?
Third one we are looking for now.
Third
I
one.
just got out of the meeting.
Third one.
T-test.
T-test. Okay. Anyone else? Yes.
T-test, ma'am.
T-test. Okay. In T-test, there are varieties. Which T-test? Sorry? Right tail T-test. No, I'm asking one sample or two samples.
One
tail, ma'am.
sample t-test.
One sample.
One sample
Field is
t-test.
generally for the hypothesis, ma'am. One sample or two samples?
One sample.
One sample. Very good.
Sample
It's a
one.
one sample case. Very good. It's a one sample case because we will be having only the batteries, right? And their life, how many hours they are working, right? So that way I can compare that mean of those hours with the given hours. That is, company is expecting that the particular, what I can say, batteries will last around or will work for at least 40 hours or more than that. That way you can compare with the known or hypothesized mean. So this is a case of one sample t-test. Is it clear?
Yes, ma'am.
Do I need to take one more?
Of course, ma'am.
Yes, ma'am.
Yes, ma'am.
So this is the last, right?
Okay, ma'am. Accordance wants to explore housing. Let's look at plan. Transportation.
Before and after wala.
Someone is
ANOVA.
ANOVA. Two-way
Okay.
ANOVA.
Ma'am, ANOVA.
Before and after.
Okay. Very good. It's a two-way ANOVA. Do I need to explain why?
Yes, ma'am. Please.
Yes. So here you can see a botanist wants to explore how sunlight exposure and watering frequency affect the plant growth. In the first line, you can find we are having three variables: sunlight exposure, watering frequency, and plant growth. So sunlight exposure, right, means for how many hours I'm keeping the plant in a sun, 2 hours, 3 hours, something, right? So maybe that can be one thing. Or second thing is watering frequency, how frequently I'm watering the plant, or twice, thrice, something in a week. And that way 40 seeds, means total 40 seeds were planted. So after a 2 months period, the record means their length was recorded, that what is the growth of a plant of those 40 plants. So we are having the length of the plant, sunlight exposure, how much time we have kept the plant in a sun, and how frequently we have watered that plant. So that way you can see we are having these three variables. Two variables are categorical, and one variable is a numeric variable. So we can go for checking which variable is impacting individually or simultaneously the growth of the plant. So we can go for the two-way ANOVA. Is it clear?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. So I think I'll conclude the whole FDP now. Today is the 5th day. So we can say in the 5 days we have seen the descriptive statistics, and in inferential statistics we have seen both kind of tests, parametric and non-parametric tests. In the non-parametric test category, I have explained you the chi-square test, and in the parametric test category we have seen T ANOVA chi-square, T ANOVA coercion and regression, right? We have used Excel for this 5 days FDP, and we have seen how Excel can help us out to perform all the type of statistical tests, which I have just taken the name, right? So I hope, friend, this FDP can help you out to make your basics clear, and now you can apply or use Excel for performing these tests, which we have learned in this FDP. So this is all from my side for this FDP. From Monday, we are starting the next FDP, which is on R programming. So those who are interested to learn R, because R is a very easy software, right? So if you want to learn R, you can join the FDP, which is starting from 7th July. It will long till 17th of July. It's a 10 days FDP, where I'm talking about the interface of R and R Studio, and we will see how R can help us for the programming, for the applying or for the analyzing of the statistical data, because R is a statistical programming language, right? So this is all from my side. Now, before ending the session, I request you, if you can switch on your cameras and I can capture you. Those who can wish or who are able to switch on their cameras, they can, so that I can capture, and then we can close the meeting for the day. Okay, Ranveer Kaur ma'am. Hi, ma'am. Yes, ma'am. Hi.
Hello, ma'am. I have one question.
Yeah.
Ma'am, prerequisite terms for R programming?
Generally, man, as I don't know how many of you are comfortable with the programming languages, but what we will do using because R is very easy software, a very easy programming language, right? You will not face any problem when you will understand R, but little bit of what I can say, coding you need to know. Coding in the sense how we are defining the variable. We are writing x equals to y. So same kind of things which we are writing on a copy, same thing you need to type in an interface. So that is not that much tough.
Okay.
Right? So I don't
And
think
what-
so. Yes, you will face any problem if you will learn R, because even I have learned R and now I'm teaching R. So I can say this thing, it is not tough. Yes.
And what are the applications? What are the applications?
Means you can apply R in your statistical analysis, right? Generally, there are two programming languages which are mostly used by the people, right? R and Python, right? But
Yes, ma'am.
R is a programming language which can help us in the statistical point of view. Means academicians are using R programming over Python. Whenever we are talking about the corporate world, in the corporate world, people are using Python rather than using R. So we belong to the academic side, so that way we can learn R, because R is a programming language which is very rich in terms of packages and libraries, right? So if we want to perform various kinds of packages or various kinds of tools, like if you want to go for time series analysis, if you want to go for bibliometric analysis, if you want to go for like CFA, SCM, etc. So every kind of packages are available. Although in this FDP we will not go up to that level, But yes, if you wish, I can tell you the name of the various packages that you can use, because nowadays there is an insertion of AI tools, right? So you can get the coding from the AI. You can replace the few things if you have idea about how to work in R. So you can replace those things in that particular coding, and that way you can generate your own outputs. So there is no problem in that.
Okay, ma'am. Thank you for a wonderful explanation. And I really, what I can say means I really impressed the way of you calmly you are conducting your whole session.
Thank you so much, ma'am.
Yes.
Okay, so thank you so much, Vaishali ma'am, Pallavi ma'am,
Thank you, ma'am.
Subreet ma'am, Ranveet ma'am, Sudesh Nep,
Sudeshna.
Sudeshna ma'am. I think P is also there. Sudeshna ma'am, Indrani ma'am, and Ketki ma'am for switching on your cameras, and everyone, those who have joined this FDP and interacted with me. Thank you so much. It means a lot
Thank you,
that
ma'am.
you have interacted. Thank you so much.
Ma'am, your FDPs are really wonderful.
Thank you, Ketki ma'am. I think you said so.
I always join. Yeah, ma'am. Today actually I was traveling, so I could not work with you on Excel simultaneously. So I was not answering anything.
No issues, Ketki ma'am. We know this thing. You are very, very interactive, and you do a hands-on along with me throughout all the 4 days. No issues. You can use YouTube for the today's session. No problem in that.
Yes, ma'am. Thank you,
Ketki
ma'am.
ma'am,
Thank you.
Ketki ma'am. Yeah.
Ketki ma'am,
Chanchala
we
ma'am,
can help each other.
Yes, ma'am.
Chanchala
In
ma'am,
what? Yeah, Pallavi ma'am.
Yes.
Ketki ma'am, I'm telling even we can help each other also. Now.
Yeah. Yes.
Yes,
I think
yes.
these are the platforms where we can increase our what I can say networking, and that way we
Okay.
can
Yes, ma'am.
maybe in future also.
Yes, ma'am.
Yes.
Yes.
It would be a pleasure,
Very
ma'am.
true. Sure, sure, ma'am. I'll connect with you, ma'am.
Chanchala ma'am.
Not,
Thank
not
you,
with
ma'am.
me, with everyone. Ketki ma'am, with
With
everyone.
everyone. Yes,
Yes.
yes, ma'am.
Yes. Yes.
Chanchala ma'am, I
Yes.
want to add on. I want to add on one more sentence for Ketki ma'am. If she is
Yes.
not mine, she is so innocent. I like her attitude
Yes,
and all.
I said this thing. She's very cute. Yes.
Yes, she is so
Thank you,
innocent.
ma'am. Thank you.
True, ma'am. It's true.
Thank you, ma'am.
Actually, we felt like that we were studying in a college. After a long time, we were enjoying that class thing
Atmosphere.
actually.
Yes.
Yeah, class atmosphere actually.
Yes.
And very calm teacher for us actually. We didn't found this kind of teacher till now actually, this calm, this much calm. Thank you so much,
Yes, ma'am.
Chanchala ma'am.
Thank you, ma'am.
Yes, ma'am. It was really lovely, ma'am. Come to our college for teaching, ma'am.
Okay. Okay, ma'am. Please call me. So whenever it is possible for me, I will definitely come.
Yes, ma'am. Sure, sure.
Yeah.
Yeah, whenever
Yes,
there will
ma'am,
be
to
any
us
kind of
also.
any workshop or something regarding any kind of research thing, please, Chanchala ma'am, let us know so that we can meet once again and we can have a conversation over there also.
Definitely,
Thank
definitely.
you.
No problem, Swati ma'am. Definitely. I think face-to-face interaction maybe will bring more things to us.
Yes,
Actually,
ma'am.
Yes,
yeah,
ma'am.
that,
Yes.
Yes.
that is more
Ma'am, do you
Definitely.
take on SPSS also these
Yes,
classes?
yes. Yes, I'm taking on SPSS also, R also, Excel also. Probably sooner I'll come with the Tableau and Power BI also, because I'm teaching these also, but I haven't introduced these softwares as a workshop or FDP mode.
Uh, Ma'am, can I get your profile? Means where shall I visit, or means if you don't mind, can you share your any kind of website or other things so I can go with your profile?
Ma'am, I think I'm available on LinkedIn. You can connect me on LinkedIn, right? And I think my number is also there on a WhatsApp, right?
Okay,
So you
okay.
can take my number, and maybe in future if you want to discuss something or interact with me, we can do that.
Definitely, definitely, ma'am. I want your email ID so I can just communicate officially.
So you can connect me on WhatsApp. That way I'll share my mail ID to you. Or maybe if you wish, I can write here also.
Yes, ma'am. It will be
yeah,
helpful
please,
for
ma'am,
us.
please.
Yes,
Yeah.
please.
Chanchala ma'am, I'm more interested in Power BI. If
Okay.
ever you are going to take a session on Power BI, please let us know.
Definitely, ma'am. Actually, I'm teaching since last 2-3 semesters. I'm teaching here in my college, the Power BI. So now I'm planning to launch at least 2 days workshop, so that way I can get an idea what type of things people are wanting using Power BI. Because to teach students is a little like the way I am guiding them in that same direction they are going. But what exactly faculty members are wanting, that I need to little see. So I'll do a trial for 2 days workshop for Power BI, and that way, if it will go good, it is fine. If people are requiring some more thing, that way I'll add on to that workshop, and then I'll bring a new kind
I
of new
have
workshop.
full confidence that it will go very good because I have attended your workshop and you explained so well, ma'am. So that